Welcome to our presentation on SQL Best Practices. In this presentation, we're just going to go over some of the best practices that Triumph Tech has adopted and that we want to share with you to hopefully help make your SQL more readable, more performant, more scalable. And so let's dive in. Before we get too far, just a quick note that the SQL that's in this presentation, it's been copied and pasted from different places, and may not work 100% exactly as copied out of this presentation. There could be errors out there, so just gotta let you know. Okay, SQL and Rock. Before we can talk about best practices, a word about using SQL and Rock in general. Rock is built with a lovely set of castle walls around it, and those are, all the business logic that we build into Rock to make sure that, you can't do things that you're not allowed to do. Of course, when you're using SQL, you are outside the castle walls, and so the best practice with SQL is really to use something else if you can avoid SQL. If you can get what you need from like a data view or a report or using Lava or some other method, typically those are better because they're within the castle walls. But you do need to use SQL sometimes. It happens, so if you have to, just be careful with it. And when you do write your SQL, you want it to be clean and consistent and performant, and that's what we're going to look at here in this presentation. So we'll start with just formatting, how the SQL is formatted, because if you're dealing with something like this, it's kind of a mess. It's intimidating. It's overwhelming. If anybody needed to actually do anything with any of these wires, they might have kind of a tough time versus, something like this where it's easy to tell what's going on and which wires are coming from where. And this is a lot less intimidating to approach compared to the other set of wires. And the same thing applies to SQL. We see SQL like this out in the wild all the time, and it's very inconsistent. It's not formatted well, so it's hard to tell what it's doing. It just doesn't look very good. And you can tell when you clean it up and format it how much better it is and how much more approachable it is, not only for yourself later, but for other people who might be looking at it. So there's a lot of value in proper formatting. So let's break down here at Triumph some of the best practices that we've adopted with regard to formatting. So the first one is that we have keywords always in caps. All keywords are always uppercase all the time. Also, you'll notice that table names, field names, and field alias names are always enclosed in brackets. You'll also note that all of these are mixed case or Pascal case. And so again, even though you don't need to capture things in brackets, we do it as a best practice because there are times when you need to, especially if you're working with groups or the group table, for instance. You need to have it in brackets so SQL knows that you're not trying to do a group by or something like that. So just use brackets all the time. We also, when we're joining tables, we use this inner join, or outer join or whatever it is. We use this type of format as opposed to having your join conditions in the where clause, which you can also do too. You can just list your tables in the from and have all your conditions in the where clause. We don't do it that way. We follow this standard of inner join and then the table and then on and then the fields that you're joining on. We follow that pattern. You'll also notice that we have inner join explicitly written out. So we have inner and join as opposed to you can just write join. And that should work the same way, but we make it explicit that we're doing an inner join. Just helps for clarity. Like the prior slide, outer joins should be fully written out as well. So here we're spelling it out: left outer join. We would put right outer join or full outer join. We'd fully write it out, make it very explicit what we're doing. Another pattern that we follow is that the table being joined should be the first table referenced in the on condition. So here you can see we're joining the person alias table to personal device. And when we do that, we're leading with the person alias table with that field. And then same thing with the inner join to the person table. Right after our on keyword, we're leading with the person tables field in that case. So the first of the on conditions should be the table that's being joined. Always use as when giving field aliases, but you'll note that we don't have as for table aliases. So that's just the way that we've decided to do it, again, just for consistency, and we feel that it helps with clarity. So we use as with field aliases, not for table aliases. Indentations and spacing are also important for formatting. So we'll put a tab after the main keywords in the query. So after our select statement, after our from, after the where and the order by, there's always a tab in there. And then we put a single space after the comma in lists. So you'll notice a space between the top there and the select is active and its comma. We put just a single space in there. If we had multiple order by conditions, we would list that out the same way, where they'd be listed vertically with a leading comma separating them with one space in between the comma and the field name. You can also insert data, of course, and so when you're doing that, we have a pretty basic formula for it. All the same rules that we just mentioned for the other slides apply here as well. So this one, if you're doing inserts, it really just comes down to formatting, that you'll have your insert into table name, that'll be your first line, and then your second line indented is the fields that you're going to insert. And then again, you have values, which will be left aligned, and then below that indented is the values that you're going to be inserting into. And similarly, when you're making an update, this is the pattern that we follow for updates. So you can see it leads off with, we're going to update the group table, and then on a new line, everything is indented after this. We're going to set our field names to those values, and then where, in this case, ID equals 12, and we'll write it out like that. All right, let's take a look at comments, which are really, really helpful to have in your SQL, and we'll just cover briefly how to use them and some cases when you might use them. So to start off with, you have these single line comments, which is dash dash, and in this case we're using it to indicate that that 3 represents the South Campus. So if we didn't have that comment in there, we would have no way of knowing what 3 means or what it's referring to. So adding in comments to your SQL on individual lines like that can be super helpful for the next person coming along, or even for yourself later, so that you know exactly what's going on. Probably a better way to do this would be to kind of black box your query, is what we call that. So you've got a declare statement up at the top. So we're declaring the variable instead of hard coding a number down in our logic in the main part of our SQL. We still have a comment on there indicating that that's the South Campus. So we're still clear on what 3 means. And then you'll notice there's a big long comment line between the declare and then the rest of the query. And you do that so that if you need to make changes to the query, at least to the parameters, you don't have to actually change anything in the query itself. That way you can use the query in different contexts, but not have to worry about changing any of the logic of the query. So a nice separation there between your declared variables and the rest of your query. And of course you can use block comments, if you need to. If you have a particularly nuanced bit of SQL that might require some explanation, you can use a block comment to clarify what's going on, and that's perfectly acceptable, and again can help you and others who may look at your SQL later. One of the most helpful pieces of comments in SQL is what we call kind of the title block. And it's that big chunk up at the top there where we list the author, the creation date. We'll give a description of what the SQL is supposed to do. You'll also sometimes find if there have been changes made to the SQL, you'll see another item there, just like author, create date, description. You'll see a fourth item for a change log, or a change history where somebody can come in and write out, what changes have been made from the original. So it's all right there in one spot at the top of the query. All right, next we have some tips for performance and scale. So these are good ideas that'll pay dividends as the query grows, or if you're working with a lot of data. Some of these will help with performance, and they're not related to formatting in any way, just performance and scale. All right, so if you just need to verify the existence of a value in a table, try to use exists instead of in. Because the exists process exits as soon as it finds the search value, whereas in, if you're looking at a table, it'll scan the entire table. And so in should only be used for finding values in lists, and that's it. If you can use an exists, use an exists because it'll stop once it finds whatever it is that you're looking for. It won't go through, in this case, and do a whole scan of the group member table. It'll just find its person if it's there and then stop looking. And by the same token, try to use not exists as opposed to not in. Try to avoid using functions in the where clause because it could be costly for the optimizer. The optimizer will not utilize index or the bucket if there are any functions on that particular column. So in this case, this would be the correct way to do it, what you see on the slide. The s.completed date time is in our select, and so we don't want to use a function on that. So if there was a like some kind of field type error between completed date time and the other end of what you're trying to compare it to, apply the function to the other part, not the part that's being captured in your select. And again, the reason for that is it might not find the right index if it finds that there are functions on that column. So in this case, if we had step ID somewhere in the query, we would also make sure don't put any functions on step ID. The group by function can be a little bit faster if you consider cardinality carefully. So what you want to do is place unique column values like ID or GUID first in the group by column list. So in this query, we're grouping by the ID first and then by names. And not just because that's how it's listed in the select, but because the ID is going to have unique column values in it, so we're going to list that first. If you can, try to avoid using select star because it goes out and gets a bunch of data that you might not need. So use the top function if you just need a sample or specify the columns that you actually want to select. But a select star is pretty taxing, and often you don't really need it. The top 10 or specific columns usually will get you what you need. The having clause should only be used when there's a need to create a condition using an aggregate function. In all other cases, the where clause is a better choice for that kind of thing. So the reason for that is that the having statement is always executed after the query, even though in the code it's a part of the query. So using having will almost always result in a slightly longer computing time because it tacks it onto the end. Versus if you can have that condition in your where statement, that would be ideal, and your query will run a little faster. You'll want to query only for the columns that you need. Because there are performance consequences for querying for extra columns, and it's possible that it might not use the best possible index. Even though you can, don't use column numbers in the order by clause. So here we're explicitly calling out the fields that we're ordering by. This isn't so much for performance, but really usability, readability, and scalability, because you can order by 1, 2, and that'll work, or in this case 1, 3, and you get the same results, but we don't do that. We want to make it explicit which fields we're ordering by. Makes it much easier to work with the query if you're ever changing the columns in your select. Also makes it much easier so you don't have to try and map the order by back to your select and try and figure out which one was number 3, which one was number 4. It's all just listed for you explicitly. We touched on this when we were talking about comments, but again, this is called black boxing, where we have our sort of hard-coded values up at the top of the query. And if you can do that whenever and wherever possible. And that just makes it easy because you only have to change things in one place. You don't have to worry about impacting the logic of the query itself. You can just change the parameter values, and it just makes it cleaner, easier, and less prone to errors because you're not in the query messing around with things. Avoid using distinct. It just causes extra processing, and sometimes you need it, but if you don't, avoid it if you can. And a good note on that is that you'll get the same result if you just group by the columns that you're selecting. And so again, this is the same query as before, but in this case, we're grouping by the last name, nickname, and name. And you can see in the select, those are our columns. So if we group by all those columns, we'll get a distinct just the same way. If you can, avoid having wildcards on both sides of a string. Generally, you'll have them at the end. So in this example, we're querying for anybody with a last name that starts with DECK. So don't query for %, DECK, %. Don't do it like that where you've got the wildcard on both sides unless it's absolutely necessary. It just makes the query work really hard. A minor performance advantage can be had if you use set no count on, just like it says there. The only reason that you would have no count off, which is the default, would be if you need to know the number of rows affected by a query, which you can usually see under the Messages tab if you're using SSMS or Azure Data Studio. So yeah, if you don't need that row count, set no count on, and that's one less thing that the query has to do. It'll go a little bit faster. Although you're probably doing this already, it is better to use an in rather than a series of or statements. You'll get the same results, but this simplifies the query. Similarly, kind of like the last slide, if you can use a between instead of to and conditions, that also helps, again, with readability, and it's just easier to see exactly what's happening when you're using a between. You can do to and conditions where it's one is greater than or equal to and the other one is less than or something like that. But if you can, use between. You'll also note that numbers should not be in single quotes. You can put numbers in single quotes, and most of the time SQL will be able to figure out what you're trying to do, and it'll treat it like a number. But it has to convert a string, if you've got it in quotes, it has to convert that string to an actual number to do stuff with it. And so, again, you're forcing SQL to do conversions that aren't necessary. It'll work just a little bit harder if you're putting quotes around your numbers. And that's about all the examples that we have for you today, but there are some additional resources that you can check out. So for instance, on the community site, under the developer resources, we have a SQL formatting style guide. And some of the examples that we used in this presentation today are there, so they're nice and easy for you to reference. You'll also want to reference some of the other Triumph videos that we have out there. And in particular, if you're concerned about SQL, we have videos on pivot patterns and window functions and more. So there's plenty of other SQL content out there on the Triumph site, so be sure to check it out. And thanks for watching.